Thanks, everyone. This is Rosetta Block. My name is Leo Trudell. I'm the co-founder and COO. And we make logistics and integration software to minimize downtime of renewable energy assets. So I want to start with a problem, a really interesting problem that we identified. So wind turbine breakdowns cost operations and maintenance contractors an estimated $250 million nationwide in 2016. Judges, don't write that down yet. The market's a lot bigger. But this is just direct payments that O&M providers had to pay back to the asset owners because they weren't able to generate the availability that they signed in their O&M contracts. So this is just a function of how this market is structured. When wind farms are built, they're mostly financed with debt. And because they're financed with debt, and that requires constant interest payments and principal payments throughout the life of the project, they need some stability in revenues. And the way that they generate this stability, especially given that wind is so variable and the revenues from the energy, therefore, are variable, is that they sign O&M contracts, usually 15 to 20-year terms at the very beginning, before the project's even been commissioned, basically mandating that the O&M providers guarantee 98 or 99% uptime availability, basically throughout the life of the turbines. The problem is most O&M providers aren't really well enough equipped to do that. There are different studies that indicate where they usually fall, and they're usually somewhere between 93 and 96%. So when that value chain comes up short, or basically when the financial chain comes up short, it's up to the O&M providers to sort of fund that and pay these penalties. So if we look at the current solution now, why is it that they're not able to, that O&M providers fall short? There's really two primary reasons. So the first is that the data that they need to diagnose faults comes from a lot of different places. It's sitting on different platforms. Most wind farms are set up so that there's one condition monitoring system that reads sensors that are installed on the turbines. And when the condition monitoring system detects a fault, it sends a message to the operator telling them something's wrong with the turbine. But from there, the operator has to go through old maintenance logs. They have to look at old inspection records. They might look at troubleshooting guides. They might want to look at other sensor readouts, weather data. There are a whole bunch of different data sources that they have to consult before they can actually sort of determine what probably caused that fault, which they need to know before they dispatch maintenance workers to actually generate a fix. Otherwise, they're wasting time. So it takes a long time. It is a very repeatable process, but because the platforms, there are so many different platforms that don't talk to each other, they have to sort of dig that up manually in every case, and that takes a lot of time. The other thing that takes time in this industry is really just coordinating the logistics. You have to get a repair technician out to the site. You have to get replacement parts out to the site. You have to get heavy equipment, probably a crane, out to the site, just because these wind towers are extremely tall. And that's just for land-based wind. If you're talking about offshore wind, it's a whole different set of logistical complications. So on average, an average land-based turbine has 15.5 days per year of downtime. Many of the problems that you'll encounter just throughout the year and throughout the life of the turbine will take 4 to 5 days to fix when they really don't need to. Most of that time is just spent coordinating logistics and trying to figure out what went wrong. So this is the page where the judges can re-engage. So the global market size for this right now is about $1.5 billion. The global potential really varies a lot. I tried to pick a relatively low number, but we're not anywhere near sort of reaching a saturation point with wind. There's a lot more to be developed. So looking forward to growing with that market. So what is our solution? How can we actually fix this? So we've developed an integration platform that's able to talk to a lot of different software systems very efficiently and aggregate that initial data so that O&M contractor, or rather plant operators, don't have to do it manually every single time. We're using semantic modeling, which I don't want to get into too much, but it's an API development technique that's very efficient. It's been very successful with getting data out of buildings. We've basically extended that to renewable energy assets. This platform also is able to connect wind farm operators with everybody else in their supply chain, right? So with any logistics problem, it's really crucial that you're able to connect to the software platforms with everyone else in your supply chain so that you can coordinate the logistics when it's necessary. Again, wind farm operators have this problem where they either have to put down a significant capital investment in order to integrate manually with everybody that they're working with, or they just have to replace that job with man hours. And so what we've done is we've created a scalable platform that allows them to sort of, just be a lot more efficient and effective at coordinating solutions. So traction right now, we're very early. We're pre-revenue. We recently signed a pilot agreement with the largest small wind developer in the country. Our market plan is we want to market this to wind farm asset owners and to O&M providers. Eventually extend this to other energy and equipment assets. Starting with the Northeast region, then working to a national and then global scale. We have a great team. My co-founder and CEO is Jason Traeger, has a PhD in mechanical engineering from Berkeley, has another engineering degree from Cornell, and he comes from the building efficiency world. My background is in clean tech banking and SaaS software development, and then we have an excellent lead developer and front-end designer on staff as well. And then in the short term, so we're not actively fundraising right now, but what we're trying to do is really secure other pilot sites. Like I said, we have a small wind developer that we've recently signed a pilot with. And what we really want to do is partner with either a commercial and industrial developer / O&M provider or utility scale project and really try to extend into that world because I think we can bring a lot more value there. I think we're probably right at the end, so I'm going to wrap up, and this is just how I arrived at the numbers, if anybody's interested. Thank you.
Thank you. Leo, one question here, right here. So I'm trying to understand what is the driver at the end of the day for your service? Is it an economic argument? Is it a speed argument? Or is it some sort of service level agreement that the owner or operator has that's driving this? So I'm trying to understand the source of the origination of the pain.
I think it's an economic and operational argument. It's an economic argument because if we can actually provide better solutions to O&M providers, then we're going to be able to help their bottom line because they won't have to pay those penalties at the end of each reconciliation period. But it's also an operational argument because with all the discovery calls that we've had and all the interviews and meetings that we've had, O&M operators work pretty hard. They work a lot of overtime trying to solve problems. They have a huge backlog, and they constantly have turbines in their maintenance portfolio that are experiencing downtime that they want to get back up. So we have an opportunity to help with that.
What are your thoughts about the economics, the pricing? Is it based on savings? Is it based on a fixed fee?
So we're exploring both. I don't really want to get into the savings game because I don't want to sort of bear that cost of having to monitor how much savings they're generating or how much electricity they're generating. I think a per kilowatt price tag works. The price tag that we've discussed with the small wind developer is 10 cents a kilowatt. We could probably charge significantly more for utility scale just because the savings are bigger there. But 10 cents a kilowatt per month. So it's relatively, for the amount of work that it takes us to integrate a turbine or a wind farm, it's a pretty good return, pretty decent payback.
And just a separate idea here, is there a different business model? Is there somebody you can partner with, the guy that goes out and fixes the problem? You know, the companies that go in and do the repair? Are they a distribution channel? Are they investors? Are they partners?
So it's a really interesting question, and I'd love to talk to you more about that afterwards. I guess the one thing that I'll say is that there are different business models, right? So in some cases you have pure O&M developers, pure O&M providers, O&M contractors. You have developers / O&M providers, and then you have companies like Bay4 that actually do the management software, the CMS software, but they have their own crew on the ground as well. So they have their own shortcomings. I think they probably overcome a lot of them with manpower the same way that other O&M providers do. But that said, I'm sure that we could help their systems as well. So I think there are numerous opportunities.
You said the asset owners require 98% efficiency,
In many cases, yeah, 98, 99.
and the operators are only providing 93 to 96. Are you able to quantify what that difference is?
In terms of dollars,
Yeah,
that was that $250 million
50 million?
very beginning.
Okay.
Excellent. Thank you very much.